Penny, do you know what a half-life is? No. Do you want to learn?
So we talk about half-lives of what they are and how we're going to solve them. A half-life is the time required for a half-life of the original sample of the radioactive nuclei to decay. A radiochemical dating determines age of an object by measuring the amount of a certain radioisotope. It is also called carbon dating. Half-lives range from thousands of a second to 4.5 billion years for uranium.
Half-lives vary greatly for different isotopes, from a few seconds to millions of years.
When you solve a half-life problem, you make a chart with half-lives, grams, and days. When solving the half-life problem, every time you add a half-life, you divide the grams by 2. And afterwards you add the number of days the half-life is each time.
And now we'll do a half-life practice problem. The problem says there are 3.29 grams of iodine-126 remaining in a sample which originally contained 26.3 grams of iodine-126. The half-life of I-126 is 13 days. How old is the original sample?
You start off with 0 half-lives, 26.3 grams, and 0 days. After 1 half-life, you divide 26.3 grams to get 13.15, and that is in the first 13 days. You're trying to get to 3.12, so you have to keep going. After 2 days, or 2 half-lives, you divide it again and get 6.575 grams, and you add another 13 days to make it 26. You're still not at 3.29 grams, so you go to another half-life, you get 3.29 and 39 days. You got your sample of how much is remaining after 39 days. So the answer is, the sample is 39 days old.
Now we're going to do half-life practice problem number 2. What is the half-life of a radioisotope which has 5.859 times 10 to the negative 1 grams remaining of a 75 gram sample after 707 days? To start off, you make your chart with your column for half-lives and columns for grams. To make this easier, we're going to move the decimal point over 1 time because it's 10 to the negative 1. So to start, you take your first half-life. Instead of dividing it by 2, like the last problem, we're going to multiply by 2 because we're looking for how long the half-life is. So if you take 0.5859 times 2, you get 1.1718. Then you keep going till you're gonna try to keep going until you get 75 grams. So you go again, multiply by 2, and you get 2.3436. You keep going to your third half-life, you get 4.68. Go again, and you get 9.37. If we go again, we get 18.74. Add another half-life, multiply by 2 again, get 37.49. If you go again, add another half-life, you'll get 74.99, which equals 75, which is how much of the sample is remaining. Since we know that it took 707 days, we are going to divide 707 by 7 because it took 7 half-lives, which equals 101. 101 is the length of the half-life.